Good afternoon, everyone. I'm Bo-Ming Yang, a master's student from the University of Tokyo. I'm very glad to present our work today, Going Beyond Local, the global graph-enhanced personalized news recommendations. And this work is a collaboration with Dai Liu and Rui Haidong from University College Dublin and Toyotaro Suzumura Erin Lee from the University of Tokyo. And first, I want to introduce personalized news recommendation. News website and platform, such as MSN News, aim to retain users by selecting the interest news articles according to the user's personal interests. This is not only elevated users' information overload, but also enhance their users' experience. Although we could use conventional recommendation algorithm, but news recommendation has its unique features and challenges. Rich textual information could be beneficial, but a significant challenge is the short life cycles of news articles. And articles might become out of date just very soon, 2 or 3 days. Additionally, users' interests can be very diverse and dynamic, and this also adding extra challenges to the task. And next, I would like to discuss some limitation of current news recommendation methods. Because of the rich textual information and short life cycles of news article, content-based methods become the most popular direction. Most content-based methods only let users use a local view, specific individual user reading history to lend the user interest representation. And other part, existing graph-based methods construct graphs through topic-related or entity-related connections, still limiting the approach to semantic connections graphs. However, some hidden connections might require a global view to uncover. As shown in the figure, user one has read orange news. According to traditional methods, we might only recommend the news closely related to the orange ones, but through a global news graph, we can discover hidden link between orange, blue, and green from the history of user 2 and user 3. And this allowed us to recommend news related to the blue and green to user 1. And therefore, in this work, Global Local News Recommendation System, in short, GLORY, we first introduced a global news graph and the global entity graph constructed based on a global user's history in the field of news recommendation. Secondly, we have designed a global aware history news encoder and global aware candidate news encoder. Finally, we achieved the state-of-the-art performance on multiple real-world data sets. About the framework, I will introduce the overview first and the global graph second. About the overview, for each user, we extract a global news subgraph from the global news graph based on this user's historical news to lend their global representation and use the aggregator to fuse the local representation and the local global representation of each news. Then through a user encoder to lend the final user interest embedding. And at the same time, to discover more hidden connections, we also extract adjacent entities from the candidate news to enhance the candidate news representation, and by the similar way, use an aggregator to generate the final candidate news representation embedding. And in the second slide, I will introduce how to construct the global news graph and the global entity graph. We treat each news article as a node. and each user's reading history as it passed, connecting news nodes in the order they were read beside this path. The weight of the age depends on the frequency of the connections. Similarly, we connect the entities within news articles based on the same path. However, to capture broader relevant connections, we use undirected edges and fully connected in the entity graphs. And later, we will discuss the impact of different effective of graph construction methods. And for the experiments, let me first introduce the dataset we use. The first one is mine, an open news recommendation dataset from Microsoft News, collects 6 weeks logs. And I think this is the most famous open dataset in news recommendation. And there are 2 versions. The large one has 1 million users, while the smaller version random samples 50,000 users from the large one. And the second dataset is Addresser, an open news dataset from the Norwegian news website, and collected 1 week's logs. And I think this was the most famous one before mine. Here we present performance tables of Glory compared to some baseline models above dataset. We use 4 evaluation metrics: AUC, MRR, NDCG5, and NDCG10. And we compare Glory with 3 groups methods. First one is the collaborative filtering methods, includes libfm, deepfm. Because the candidate news just have very few interactions, they got the worst performance because the cold start problem. And the second group is neural network methods, which just focus on content-based, the local view, just on individual user history. And the third group is graph-based methods, either find the category relationship or semantic relationship to build a graph. Finally, our Glory achieved the best performance on nearly all the metrics among all the 3 groups methods. And for the ablation experiments, we investigate the impact of the global news graph and the global entity graph. We can show that those global graphs provide hidden information beyond local semantics and can effectively improve the performance of news recommendations, especially the global news graph component. And the second experiment studied the impact of different graph encoders. GGNN outperformed GATE, GraphSage, and GCN in the comparison, which is likely due to the GGNN utilizing GRU can learn the hidden sequential information better underlying user reading history. And next, we continue with hyperparameter experiments. We study the number of hops and the number of neighbors when extracting the global news subgraph from the global graph, and also as well the number of adjacency entities in the global entity graph. We also provide the computational time cost ratios for different number of hops, and according to the figures, we can clearly see that large hyperparameters lead to more complex subgraphs, thereby consuming more computational resource. However, excessively large hyperparameters can introduce too much noise. And the optimized combination of hyperparameters depends on the structure of the dataset, so it's not fit for every dataset. And in this section, I want to show the effect of graph construction methods. For the global news graph, there are 3 experiments: undirected connection between news, directed connection between news, and the co-occurrence on the same path. From the table, you can conduct that a directed global news graph achieves the best performance, which might effectively show the temporal features of user reading interest. And for the global entity graphs, there are 2 decisions towards to 4 experiments. 4 experiments whether entities within news are connected or not, whether connections between news are directed or undirected. So this is 4 experiments here. The result shows that a global entity graph with not connections within news and undirected connections between news achieves the best performance, likely because it keeps the hidden connection information in the global history while reducing semantically noise. And next, we demonstrate the advantage of glory through a case study. And all the categories and the subcategories for these figures just for a reference only. In glory, we just use the news titles and entities. The blue table shows the reading history of a random selected user, and the green table shows news related to the football and sports from the subgraph. And the origin table shows the news that the user actually read from the candidate news. We can clearly see that these user interests are not all related to sports or football, but they choose to read football news in candidate. Therefore, an RMS, which is based on a local view, a content-based methods, rank this candidate news at 38th place. However, we can see hidden connections from the glory subgraph. The NFL team Dallas Cowboys is located in Texas, and the user's reading history of social news, the first one about Texas, indicated an interest of this state. And here we come to the conclusion. We present Glory, which utilizes global news entity graph to capture hidden behavior and patterns of all user reading history. This approach addresses the limitation of relying solely on semantic news modeling. And I think there are 3 directions for the future work. First one is we can use pre-trained language model or large language model to improve the news content representation. And also, in the online test, the time dynamic is also very important, so we can add dynamic to the global graphs. And the third, we can study complex or different graph construction, the extracting methods of subgraph, and also choose different graph encoder to find a more effectively graph encoder for this task. And this is all for my presentation. Here are QR code of our paper and codes. Thank you so much. Now it's open for the question.
Thank you, Boming. Very interesting work. I have a question that sort of links to your future work, because I see you're talking about news in your future work, but this model seems to be applicable to quite many other domains. So why not try it out on something else?
You mean why we would try the PMM or LMM models?
So something else than news.
Actually, these are limitations of our work, because if we want to extract the subgraph of the single users, the graph will contain maybe hundreds or thousands new nodes in single subgraph. So if we just pre-train like with the BERT model, the computational cost will take out huge. So this is, but I think the large language model will solve this problem because we can just use we can use large language model to summarize the graph or summarize the news content to shorter titles or shorter sentence. So maybe will solve the limitation of computational course.
Okay, thank you. Do we have any questions from the audience? Kim?
Is it on? It's on. Okay. Thank you for an interesting talk. I was wondering, one of the bigger problems with news recommendations is the filter bubbles. And for me, it seems that this actually enforces filter bubbles much more. Have you thought about how to break out of those ones?
Sorry? Sorry?
A filter bubble means that you recommend only the same things, only the good things that people are interested in. Oh. Have you considered how to avoid ending up in that situation?
Oh, cool. This is I think this is another question, a big question called diversity recommendation in the news recommendation. I think in our methods, this is a great performance in diversity metrics because we not only based on the semantic content. So if we just, like the case study I've introduced, if you just interested in some traveling, but maybe you recommend the recommendation list will show some paths or entertainment because of the same interest group of, because other users have this interest path. So we can following other users' paths to recommend to you another categories news articles.
Okay.
Thank you.
Hello, very interesting talk. So I noticed in the, you considered the user news consumption sequence when you are doing the modeling, but in the comparison baseline in the experiments, you didn't, I'm not sure if you have compared with some sequential recommendation models, and have you checked out how does your model perform compared with those kind of standard or sequence models?
Oh, cool. Sequence model is also another popular topic in news recommendation. And actually in the LSTUR, one of the content-based baseline on our main result table is considered the sequential, the long-term different user interests. And also this I selected this method, baseline methods into the content-based group because it's also just use a local view, just based on the same individual user reading history. So I think our models just outperform than those similar methods. Yeah.
Yeah. So mainly, you are mainly just comparing with the content-based recommendation algorithms.
Yeah.
Okay.
For now, yeah.
Got it. Thank you.
Thank you so much.
So we have a question online, and that's given how fast users' interests change and how fast news trends are, how often should the global graph be updated?
Oh, wow, cool. How often should this update? I think this depends on the platform. If some special news platform, maybe sports or maybe traveling platform, there's not such update sequence demand. But if there are some business news or the social news, I think the update frequency will very high. I think this is an open question, depends on the different platform and different news data set.
Okay, thank you.
Thank you so much.
That was our third paper in this session, and next up we have masked and swapped sequence modeling for next novel basket recommendation and grocery shopping by Meng Li from a team from University of Amsterdam. Take it away.